I would like to welcome on stage our next speaker, Michelantonio Trizio, Digital Entrepreneur, XR Engineer, and CTO at Whiteverse.
Michelantonio is the CTO of Whiteverse, a spin-off of the Polytechnic University of Bari that works on XR and AI technologies. In addition, he's the founder and the current lead of Google developer group Bari Community. He had been the content manager for the Italina Code Motion conferences between 2021 and 2022. Today, he will talk to us about how we can tune our world into a canvas with augmented reality.
Thank you.
Welcome, Michelantonio.
Welcome on stage.
Hello, I'm so happy to be here today. This is my first time in Greece. And now we are going to understand how we can make the world your canvas with augmented reality. So this is a few words about me. I'm a computer engineer. I'm the CTO of this spin-off Polytechnic University of Bari. And in addition, I'm the Google developer group Bari lead. And this is me when I'm not behind the screen of the computer. OK. First of all, some questions. How many of you are Unity 3D developer? Few? OK. Oh, just one. OK. OK, OK. So I think that is the guy that answered yes to my following question. That is, how many of you are working on augmented reality? You. OK, perfect. And I think that one important question here is why at the AI age is still relevant talking about augmented reality and mixed reality. Fundamentally, because of this, because a lot of metaverse companies are switching to spatial computing, and there is a deep connection between augmented reality and AI in spatial computing. Indeed, I swear, this is the ugliest slide of my talk. We can see the difference between metaverse and spatial computing paradigm. From metaverse side, metaverse is an immersive virtual experience opposite to the physical world. Instead, in spatial computing, we have a deep integration between digital and the physical world. Talking about technologies, in metaverse, we have virtual reality, powerful graphic cards, and advanced networking interfaces. While with spatial computing, we have augmented reality, spatial recognition sensors, and computer vision algorithms. A lot of computer vision algorithms. Talking about the use cases, in metaverse, we have entertainment, social media, gaming, and virtual commerce. While in spatial computing, we have industry, healthcare, design, and education. Regarding the adoption, as we know and as we have seen in the last years, the metaverse has ambitious but uncertain vision, while spatial computing has a more pragmatic vision and immediate and feasible applications. So this is the immersive computing spectrum presented by Google at I/O 2017, when we can see on the left, our reality, what we can see with our eyes. In the middle, we have augmented reality, where we can see an initial computer-generated content, where we have our reality that is overlaps by a virtual layer. And then on the right, we have virtual reality where we are totally overlaps by computer-generated content. So one image is more powerful than 1,000 words. So I hope that all of you have seen the Space Jam movie with Michael Jordan. In the first part of the film, when he visits the cartoon world, this is virtual reality. In the second part of the film, when Bugs Bunny and its friend play basketball match in the reality, this is augmented reality. So as Kunal Kona said, he's a software developer at Facebook Reality Labs, in VR, the screen becomes your world, but in AR, the words become your screen. So let's look deep into AR and mixed reality differences. So this is augmented reality. So if we put a virtual ball on a real table, and when the ball reaches the edge of the table, it continues to fly in the air, because in classical augmented reality, the ball doesn't have the perception of the table. Instead, in mixed reality, there is a deep connection between physical and digital environment. So when the ball reaches the edge, it falls down because of gravity. So mixed reality have a deep connection between physical and digital. Now, talking about Google, we know that Google mission is organize the world's information and make it universally accessible and useful. And the Google AR team translates this mission into make the real world a launcher for helpful and delightful immersive experiences. In which way? Building AR Core. That is the SDK developed by Google that allows us to create immersive experience with our smartphones. But let's make a little jump into the past. All the modern architecture of AR devices and software are related to the Project Tango, that was a Google project. And if we can see the complete timeline of augmented reality, we can see a bit of history. We can start with Sensorama in 1962. That was a machine where you can put your head. You can see some 3D images, or you can feel some sensation like the wind. Then, in 1968, we had the first head-mounted display. That is quite similar with that one we used to see in these years, but with a great difference. The headset is wired with a long cable with a mainframe that was in another room. Then we arrived in 2012 with Google Glasses. That was the first real augmented reality headset. So not so real, because the prism is not aligned with your eye. So you have to look up to read the information on the display. Not real augmented reality, because it doesn't overlap the reality with a virtual layer. Then, in 2014, we had Project Tango. And in 2016, we had Microsoft HoloLens, that was the first headset with mixed reality capabilities. Then, in 2017 and 18, we had ARKit and AR Core. There is a long and funny story about those SDK, but I have no time during this presentation to talk about it. So, talking about the hardware of Project Tango, you can see some important things like the fisheye camera that gives a wide angle for framing the environment. Then we have a lot of inertial sensors that gives the precision. And finally, we have an infrared projector and an RGB infrared camera that give to the device the capabilities to perceive the depth. In fact, on the bottom right image, you can see how this device can understand the reality. So, like a point cloud. But ArcCore and ArcKit work on your devices without the need of infrared, and that is thanks to these three capabilities. First of all is motion tracking. In few words, motion tracking is the capability to translate one movement in the reality, one step, into a movement into the virtual world. So this is accomplished with the SLAM process that taking the image that is framed by your camera, identify some feature point, and use the movement of this feature point to translate real movement into a virtual one. Then we have environment and depth understanding. So thanks to computer vision algorithms, we can understand the surfaces of our environment, like ground or instead table and wall too. And in addition, we can perceive the depth because ARCore gives us a depth map of our image, and it enables occlusion. So occlusion is when you can hide a 3D model behind another real object. For instance, I can take a Pikachu 3D model, and I can put Pikachu behind the signal, so you can experience a more natural, in more natural way, your augmented reality application. Last one is light estimation. So taking the light estimation from our light sensor enables us to light our 3D model in more natural way surrounding with the environment. Okay, this is all the skill tree of the feature of ARCore. Some of them we already talk about. There are others like augmented faces. I can put some visual effects on my face in a virtual way, or instead augmented images. I can take a real image, an image, and put a 3D model on it. But today's talk is focused on geospatial functionalities that are cloud services, and they work both on Android and iOS devices. So let's start with the ARCore Geospatial API. We will see 3 services. And now I will show you some samples. For instance, have you ever tried, if the network, okay. Have you ever tried Google Maps with augmented reality? Raise your hands. Okay, fine. This is based on ARCore. Another use case is entertainment. Gorillaz made a concert with Google, a virtual concert in Google in Times Square, using ARCore, making an immersive, totally immersive experience. Another sample is gaming. Taito renewed the Space Invader classic game with Google, creating an augmented reality version of the game. Otherwise, marketing. We have here a presentation made by Gap with Barbie, where they present their collaboration at Times Square. It seems that a lot of augmented reality things happen in Times Square. And another interesting use case is urban renovation. This is an experience that with my company realize in Bari, in our city. Bari is living deeply urban renovation, and show how the new urban landscape should appear is useful for public decision makers, and it's a new way to communicate with the citizens. Okay, but how can be it possible? As we know, GPS allows us to have a precision of 5–10 meters. And the answer is visual positioning system made by Google. Visual positioning system is a deep neural network model built on top of the 15 years of image collected for Google Street View and Google Earth. So what happens? Like for motion tracking, the model identifies the feature points of the scene that you framed with your phone and can estimate your position and your rotation into the space with a precision more or less of 1 meter. So in this way, we can put 3D object precisely into a point in all over the world. So we have 3 main features that are Geospatial API and Geospatial Creator. Geospatial Creator is a plugin for Unity 3D to develop augmented reality experience. Then we have a second feature that is a streetscape geometry that allows us to change the texture of the buildings, as we have seen before in the Gorillaz concert. And last one, we have scene semantics. Okay. Let's start in talk about Geospatial API, Geospatial Creator. We have to do some preliminary step. First of all, we have to create a project on the Google Cloud Platform. Then we have to enable MapTiles API, because in this way we can ask to Google Cloud Services to have the tiles from Google Earth inside our Unity 3D editor. Then we enable Places API, the new one, because there is either an old one. With Enable Places API, we can ask to Google some location via API. Then, obviously, we have to enable ARCore API, and then we have to create an API key that we have to provide to our application to make the request to the cloud. By the Unity side, instead, we have to add to the project AR Foundation that fundamentally is a wrapper between, is a wrapper of ARCore and ARKit. And so in this way, you have to write using the AR Foundation classes. Don't you need to know all what is under the hood if you're working with ARCore or ARKit. And the main thing is that you can build one time the application with the same code. Then you have to add the XR plugin management to manage the plugin. You have to add the ARCore extension, that is another library that is specifically target to the Geospatial API. And then we have to add Cesium that allows us to see Google Earth inside our Unity 3D editor. Okay, I made a video with a bit of experience of Unity 3D. This is the editor. Here you can see the hierarchy. The first thing that we have to do is add a creator origin of our experience, the starting point of our experience. And then we have to add the API key. Following, we can search for the center of our experience. In this case, I put the center on my house. And we can set, otherwise, we can set latitude, longitude, and date. This is the result. We have Google Earth inside our Unity 3D editor. And we can move, jump around, and make a lot of things, as in Google Earth. Then I have to add another classes, another prefab that is Geospatial Creator Anchor. This anchor is relative to the origin, and then I add a 3D model, in this case a book, as a child of our Geospatial Creator Anchor. And since then, I can move the object into the real space. As you can see, I can set up latitude, longitude, altitude. We have three kinds of altitude. I explain better when I will talk about streetscape geometry. We can set up a relative altitude of our 3D model, because if I want that the object is floating in front of me, I have to set up an height of 5-10 meters. And then I can override this altitude only on the editor, because the editor doesn't have the altitude perception. Okay, but if we want to add a new geospatial anchor by code, this is the way. So figure out that we are asking to Google the list of our the city libraries of our city. Okay, we have the result in that array. Then we have to get from the scene the AR Geospatial Creator Anchor that we have added before. And in simple way, for each place, we have to clone this object, and we have to change the latitude and the longitude according with the place's latitude and longitude. And then we can add a display name on it. So this is the result. If you launch your application, you have a view of your city with all the marker on each of city library. Okay, talking about streetscape geometry. Streetscape geometry allows us to put 3D model on the rooftop of the buildings or at the terrain level. This is possible using the data taken by Google Earth, and this is the main class that we use for to accomplish this task, that is AR streetscape geometry. There are three variables, three attributes of this class that are important. First one identifies if we are working with a terrain or a building. The second one returns the polygon mesh that you can see in these photos. And the last one provides the quality of this mesh data. Because in the top photo, you can see that there isn't the rooftop, while in the second one, we have the rooftop. It depends by the quality of the mapping data taken by Google Earth. Okay, talking about the last feature, we have scene semantics that allow us to understand what our phone is framing by the camera, and this is the complete list of what we can recognize into our environment. We can recognize sky, building, tree, road, vehicle, sidewalk, terrain, structure, water, object, and persons. What we can do with this feature, for instance, we can put 3D model of fishes into the sky. Or another thing, we can substitute all the vehicles with the Millennium Falcon Starship. Okay, we are at the end of the talk. Let's make a little recap. First of all, we understand the differences between metaverse and spatial computing. Metaverse is based on VR technology, spatial computing on AR. Then we have seen the difference between augmented reality and mixed reality. And we learn the AR core fundamentals. So motion tracking that allows us to make a step into the reality and translates it in a step into the virtual world. Then depth perception and environment recognition, so we can put our 3D models on the ground or on the wall or on a table and use the occlusion. And light estimation, which help us to better lighting 3D model in our environment. Okay. For immersive experience in open world, we've seen Google Geospatial Creator and the plugin for Unity 3D. We've seen streetscape geometry and the capability to put 3D model on the rooftop, and the capability to take the shape of the building and put on some textures like you have seen in the Gorillaz concert, and we have seen semantics to recognize some elements inside our environment. Okay, what's next? These are some of the key points for learning more about AR Core, and thank you. This is Q&A time.
Thank you, Michelangelo. I don't know why it happened. I think it's a coincidence, but we have close to half of our speakers this year from Italy. Yeah, we're happy about this, but yeah.
I'm so happy to be here.
Yeah. Do we have any questions?
Of course.
I believe we have.
Okay. A lot of questions.
How might future advancements in AR impact privacy and security, especially with location-based features?
This is a good point. because you have to give some data to the cloud to have this kind of feature, but you know, Google is working always on federated learning, so part of the computation can be made directly into the device.
Yeah, okay. Do we have time for one more? Yeah, I will take the last one. I think it's maybe it will be something useful for our community. What advice would you give to a young Unity developer that has a passion for game development but has no real experience in the industry and wants to actually work in that field?
Okay, this is a good question. First of all, there is literally a universe of languages and applications. So don't stop you on Unity, first of all, because there is Unity, is Unreal, is another framework for web XR experiences like Babylon. So I think that the better answer is looking for a community in your city or online and share your knowledge and your doubt with the community so you can learn more and more, because Unity is wonderful, but it can be a mess sometimes in a special way with the version of the editor and the version of the library. Syncing them is really a problem.
Unreal is a bit more straightforward. That's the difference.
Yeah. Okay.
Okay. Do we have one more? Yeah? Martina, do you want to take another one?
Okay. Let's take the second one. In your view, what will be the most impactful use cases for spatial computing in healthcare or all critical fields?
Okay. I can talking about experimentation that we made in surgical room in Italy. We are using HoloLens to allow the doctor to have all the useful information in front of his face in a way that it can better work on the patient. I think that this is a real and impactful use case. But as for healthcare, we have a lot of fields that are impacted by augmented reality, for instance, Industry 4.0.
Yeah. Thanks
okay,
a lot.
Great. Thank you very much.
Thank you. This one.